All right. So the first thing I need to try to do is see if I can get this undone. We had a bit of an accident, didn't we? So we've got a mismatch here, which is something for folks to think about. If you're taking grease guns apart to set them up, and could someone get confused and put the wrong pieces back together? Now, I've been in facilities where they made a conscious decision. I could explode here, so try to get over this trash can. Make a conscious decision to reduce down to one style of grease gun for the whole facility. And by doing so, you're really just eliminating this as a possibility. But what we found is in our setup, we had mismatched. The pumping section to the base section. Now I just confirmed that this is the correct base. Here's the tube section. Here's the head pumping section. And these can all go together. The problem I had earlier, right, Baia, is that the tube wouldn't fit all the way down. And when I tried to force it down, it released this handle. So I often, as I do demonstrations, caution folks to say you're really dealing with a loaded gun and be careful which way you point it. But again, to pull this spring back and turn that off to the side, you can see how it's slightly cocked. There is a slot here in the rod and then a narrower section to hold on to that, a little shoulder to hold that back. But if I should knock this up, it's going to fling forward and send whatever's in there flying. So we've lost some of the grease from this tube, but now I should be able to make it fit. Nope, still doesn't fit, and I'm a little baffled why that won't go down. It's going as far as the tube. So let's try this. I think what the problem is, now that I look at it, there we go.
Okay.
The problem here is that I also had a swollen plunger. So the plunger on here generally will run right up on the inside of that tube. So what I did this time is I deliberately held this handle section that's basically you pull back the spring pressure, held it off to the side and kind of put pressure on top. What I had done previously is I held it in the middle, put pressure on top, that released this and everything went flying. But you can see now what we have is this grease cartridge. The lip of that cartridge is now flush with the top of the tube. This is normally the step where we would peel that back, but we already did that previously. So now we're just going to have to put the head on there. And again, this is like the most dangerous time of loading a grease gun, because right now, if we knock up on that, this is flying across the room. So I'm going to be conscious of that. I have some space there. I move that off to the side. I bring the head of the grease gun over. I line that up, start that thread. There we go. And now I'm threading that in place. And it is a clear tube in this case. And we're still in a dangerous spot until we get that all the way on. And we seal right here with the threads. But now what you've got the ability to do in this setup is to see here. I'm going to just grab a towel here so I can get a better grip on this. Make sure I get it on there tightly. Now that it's on there, now I can indeed release that. Now the pressure of that plunger is on the inside of the cartridge and it's forcing the grease to the top. This just releases from that plunger if you turn it right way, and now you can kind of get it out of your way. Okay, so it's up inside the grease now. Now I could start pumping, but the problem is that there might be an air pocket here. So the way that we deal with that, and the other head was a lot nicer because it had a knurled hand thing. I actually need a wrench to get this one going, but you would loosen this up and you would hear the air kind of pop out. So let's just see if we got lucky here and we got that grease in there without an air pocket. And it appears that we did. We're actually pumping grease now. So, as if to prove my point, Loading a grease gun, not a simple operation. We had to do this in phases and stages, but it's just such a common thing. I think it's taken for granted that, yeah, it's a grease gun, just hand it to someone and tell them to go grease the fittings. It's also a fairly dangerous instrument. And when we were kind of getting ready for this, I talked about the pressures that can be generated from a grease gun. Some models go all the way up to about 15,000 PSI. So you have to be really conscious and careful about what you do. The other thing is that you want to try to keep this clean. If you're, any kind of tube, any kind of parts here. And so it's like, how do I do that? This is kind of shows, the bad practices, right? If I've got some old grease on the inside here, it's going to be obvious. People are going to see that. It's going to look lousy. Now I could cover that up by using a solid one that no one can see what's going on inside. But as we looked earlier, and I think, Baia, you might have started to clean this one up maybe. Mm-hmm. Yeah. So there's still a little bit in there, but you certainly got a lot of it out, which is great. But again, all you're doing is hiding that from, well, here's another one. And it looks pretty nasty in there. So it's like, yeah, you can't really see that. But it's still a problem because it's still potentially grease that's going into your system. So clean that up, and the best way to do that is to wipe as much of the grease away and then use soapy water. Soapy water will allow you to get that nice and clean, and consider doing that with your grease guns. Just remember, you want them to be completely dry before you start greasing again, because you don't want to be pumping water into your reservoir. So I'll move that off to the side a little bit. It'll give us a chance to go to the next phase here, which is to demonstrate that new unit, the new sampling unit, the grease thief pickpocket. All right, should we roll right into that?
Yes, we can.
Okay, super. So I don't know if it'll be better for you to change your angle at all, Baia, but here is the motor test stand that we have. You may have a good view of it over there. That might be all right. I'm going to angle a little bit towards the camera, and that might help. Mm-hmm. So what you can see here is we took an old, I believe it was a 60 horsepower Baldor motor that had failed, and as part of the root cause failure analysis, we went inside, we found some winding things, but then we said, hey, this is a nice end bell here. It was actually brand new when it failed. So we cut off the end of the end bell. We replaced it with a plexiglass window, and now we can see what's going on inside. So I don't have it powered up. I don't even have the electric connected, but you can see that just by spinning that coupling, I can get the bearing to move around inside. There's a little bit of leftover grease in the raceway of the bearing, but there really isn't anything there with respect to filling the housing. So it gives us a nice clear picture for now. I'm going to, just give me 1 second, Baia. I'm going to grab the, oh no, here it is, the other instrument. I think it's right here.
Yep.
And I'm going to, this is the Grease Thief Slim, okay? And so we developed this a number of years ago. It's had some great applications. I believe the earliest application for this was to try to address wind turbine blade bearings. We found that the openings to the main bearings were fairly large, so we could take a full-size Grease Thief and put that in, put that on a tool, reach inside, go to the depth that we want, pull it back out again. We got to some of the blade bearings, and the openings were very small. Grease Thief couldn't go in. So we developed this Grease Thief Slim to go into these smaller openings. And while we started with the blade bearings in the wind turbines, we found that there was a lot of other applications where you generally have small openings to get inside. Now here's one small opening that I get asked about a lot, and this is the Zerk fitting, or the grease fitting, hydraulic fitting, where the grease is put into the bearing. And people are like, well, I guess I just screw that out and I take that sample. Not so quick. It might work here, but in a lot of places where you have Zerk fittings, you actually net down into a much, much smaller opening. Maybe a 32nd of an inch drill hole is all you see there, or 1/16 of an inch drill hole. Nothing's going to be able to get past that. And all you'd end up with is the new grease that was pumped in here recently. What we're going to do is go to the other side here, which is where the drain plug goes, and there's an opening. So in this case, I'm going to show it as it is set up. There is an offset. Okay, I'll hold it like this. There are two blocks here. Okay, you've got the Grease Thief product name there. You've got the part number here, and you've got positions 1, 2, 3, and 4. This rod is a standoff rod. It has what we call the foot on here. The job of the foot is to hold this tool still while we enter the machine. So we can take it, and there is a hole right here. We can put that in that opening. I'm going to have to pull it out a little bit more here so I can reach that. And I'm going to insert that, and it would go until it hit that foot. Now there is a set distance inside that reservoir that I'm going to go before I start sampling. Because in this position, you can see this black piston here. It's pushing grease out of the way on its way in. Only when it gets to this position and then it's held firmly against the machine by this foot can I come down here to the slider disc and push that up. Now there's a holder here that we loosen and we push that up to core the sample. And your sample is going to be captured here and you can pull that out. So I'll show you again in the machine. It might be a little too far of an offset here. I might hit the top of the bearing before I finish the coring operation. But I'm going to slide that up. And yeah, there I hit it. So I would offset this differently in this case, but eventually you end up with that cored sample from that location, and then you tighten this screw back up to hold on to the straw as you extract it out. Now that's going to be a sample that is equivalent to a full grease thief. In fact, this tube fits right inside of the grease thief body, and you can transfer it right over to a grease thief. Remember, we say that you only need 1 gram of grease to do the whole test slate that we have for grease analysis. This is going to hold a little bit more than that. A full grease thief might be around, depends on the density of the grease, about 1.5 grams, but that's what we would get. Now there are some limitations here in terms of transferring this over or even potentially using this without a grease thief to do some testing. And sometimes all folks want to do is pull this core sample and then tell me what the metals are. Tell me what kind of wear is present. And in that case, you might not need the grease thief to go to the next level. So this is what prompted us to transition. Also, the fact that when people were using this, they were just coring the sample, they were sliding the tube forward and cutting it with scissors, and it would always be a different size, different amount of grease, and you would have, kind of leftover grease on that piston. So introducing now, this is the newer version, which is the grease thief pickpocket. Okay. A lot of similarities here. We've got the 2 blocks. The space between these blocks is really critical because it sets that coring distance. And then we have the standoff again. We've added a feature where there's a little tool that allows you to make adjustments to the set screws that are here and it holds it firmly in place there. This is going to be different in that instead of having a whole tube, it has a shorter section here at the end. And I'll just demonstrate that. So as we're going into the machine and we stop, we're again going to slide this forward to core the sample. And then we're going to transfer that into a holder or a sample vial. And it just pops that right off of the end. And now you have that 1.5 grams of grease in a small plastic vial that you're able to sample with. Again, this is really set up very similarly to the one that we showed before there. And I'll have the same problem using this here because I'll go in so far. And let's just say it stops right there. Let me just make it an internal adjustment there. By sliding that forward, again, I'm coring the sample. I tighten this up. I withdraw that. And again, that's going to go into your vial. It's going to transfer over. So it gives us that 1.5 grams that we need. That is the function of the grease thief pickpocket as the replacement for the slim. You're going to be seeing more of this. We just got a whole bunch of samples coming into the lab by one of our early adopters. He's out there in some steel mills right now taking grease samples. And this has proved to be a very simple way to do it. And when you're done, you just make sure that this part is pulled back. You get a new clean grease sleeve here, or a pickpocket sleeve with the piston, and it will pop in place when we pull that back down. And then I'm reloaded, ready to take the next sample. So that's what I wanted to show today in this application. I think there's some other things that we were looking at too for taking samples. I'm going to make that a follow-up video where we'll look at another development, which is the GT filler, or the grease thief filler. It's a replacement for a syringe. It allows us to take a sample from a pillow block bearing like we have here, and we'll set that up for another demonstration where we'll show how the grease is added. There, we got our grease gun ready to go, how the grease is added, how the sample is taken, how the GT filler plays this new role to transfer quantitatively into the grease thief or into one of these pocket tubes that we get from this process. All right, so we'll make that our work for today. If you have any questions, contact us. Go to our website, www.greasethief.com, or call the lab at 717-843-8884. Thanks.